Thank you for those kind words of introduction. I'm going to open up this prospect of human age reversal talk by letting the group know that the entire presentation, all the PowerPoints and hyperlinks are available at the agereversal.net website. And it gives you a chance to sit back and relax and not worry about scribbling down some information when you see something of interest, because the hyperlinks and the slides will all be on the agereversal.net website. I'm going to talk today about research findings since last year's RAADfest, and there's been a lot of them, including what people can do right now to live 5 more years. I'm going to talk about a study that we're funding in which we're going to seek to repopulate bone marrow from old people with autologous-induced hematopoietic stem cells to reverse immune senescence, and some transhumanist advances that have occurred over the last few months. Now, our controversial contention is that it may be possible to reverse aging in people today. And we say this based on a lot of evidence, including dozens of studies on parabiosis research, where they circulate young blood into old animals on a continuous basis, and the old animals grow biologically younger. This research has been replicated many, many times, starting from the 1950s all the way up until recent times. This motivated me to do my own study. I wanted to see, does this really extend lifespan or quality of life? And the good news is we took a group of rats, about 60 human equivalent years, and we gave them intraperitoneal injections of young rat plasma every 2 weeks. And guess what? The rats receiving the young plasma every 2 weeks lived longer, but more impressively, their quality of life was much longer. So the young plasma group, you can see with the solid black dots, and they lived longer and they lived healthier compared to the control group not receiving the young plasma. And sometimes, well, the picture really tells the story. And here you see the control group not receiving young plasma on the left. It's looking older. Its coat has lost its nice white color. It's heavier. And then the young plasma treated rat, and again, starting these at 60 human equivalent years, it looks younger and it behaved younger. Here's another picture where we have 3 of the treated rats. They look younger, and then the one without the young plasma, it looked older and it behaved older in the cage. So quality of life is a big thing. Again, another picture. On each side are young plasma treated rats. In the middle, one that didn't get the young plasma, it didn't live as long, and its quality of life was significantly reduced. One more picture, again, 2 of the treated rats on each side, the control rat in the middle, just looking older and not living as long. So here's an expanded description of this study. We intraperitoneally injected the young rat plasma into 60-year-old human equivalent rats, and we saw an extension of lifespan. Now, a human equivalent estimate of how much longer? Well, a 70-year-old human getting this treatment might live to be 77 as opposed to the control group. Very hard, though, to translate rat findings into human findings, but at least we saw survival improvements, but most impressively, a transient improvement in quality of life. And this is just a summary from the scientists who did this. This is, by the way, pre-publication research. It won't get published for a couple months. You're seeing it now as you're attending RAADfest. But young plasma seems to possess these revitalizing factors that can improve quality of life and moderately extend their lifespan also. Now, this validates a lot of work that's been done, or I should use the word corroborates. We're corroborating what's been done in dozens of other studies, including one I reported on last year at RAADfest, in which young plasma fractions more than cut in half the epigenetic age of a group of mice. And this is moving forward into a potential new drug that could enable people to grow biologically younger, maybe cut their epigenetic age in half, which would be incredible if that happened. So the big question is, what do we do now to transition these young plasma benefits into old humans? Remember, we can't continuously circulate young plasma into our bodies. It's rather inconvenient to go in every couple of weeks to get young plasma infusions, and it's not going to work as well as if we had the ability to produce young plasma in our bone marrow. And this is where most of our youth emanates from. In youth, our bone marrow produces huge numbers of mesenchymal and hematopoietic stem cells. It's releasing these stem cells into our blood 24/7, around the clock. We're literally, when it comes to hematopoietic stem cells, 1,000 billion cells a day are produced and released, immune cells, red blood cells, platelets. We grow older, unfortunately, and it declines. Our stem cell function and stem cell numbers, they decline. And unfortunately, this is a problem with aging, and we're seeking to address that. But it's important to understand that the natural way of staying young is to maintain healthy bone marrow. And the incredible news is transcription factors are able to reprogram old cells into induced pluripotent stem cells that can theoretically regenerate our tissues forever. I'm going to talk a lot about transcription factors throughout this presentation. Just to give a short definition, these are proteins that turn on and off gene expression. Under favorable conditions, the transcription factors are controlling our genes, so we have pro-youth expression of our gene patterns, as opposed to, unfortunately, the activation of the pro-aging factors. So transcription factors, very important element of what we're seeking to explain. And the Nobel Prize 2012 was awarded to two scientists who were able to identify 4 transcription factors that converted old somatic cells into pluripotent stem cells that can propagate indefinitely. They won the Nobel Prize for this work, and those 4 transcription factors are collectively called Yamanaka factors. And we're going to use this technology, we hope, in vivo to enable older people to grow biologically younger. But as it relates to our stem cells, most people think about the mesenchymal stem cells, very important for tissue maintenance and repair. But our hematopoietic stem cells, well, this is what's needed to produce our immune cells, our red blood cells, our platelets. And when we lose our hematopoietic stem cell production capability, we die. It's needed to sustain life. So we're focusing in on research right now, and the good news is in vivo. A study was done, published in 2017, showing if you take out old hematopoietic cells and then reprogram them using transcription factors to turn back on youthful gene expression patterns, guess what? You're able then to restore those old hematopoietic cells back into younger ones. They were able to transplant these back into old animals who then started to produce lots and lots of red blood cells, immune cells, platelets. They were able to prove in vivo this can work. This is a slide from this study showing how they did this. But what we want to do is translate this into the human model. And what I did last year is commissioned a review article with some prestigious scientists to evaluate all of the studies that have ever been done looking at cellular reprogramming using transcription factors to turn on beneficial genes and silence the ones that cause us to age prematurely. One of the studies showed that a 6 transcription factor cocktail was able to completely reverse the degenerative changes in old cells and fully rejuvenate these cells into youthful functionality. This stimulated interest in the scientific community. That was the purpose of funding this review, where it got published in a major journal, and people around the world could see we're on the verge of making a major breakthrough in vivo. Here's a little diagram of how we intend to induce aging reversal in people, elderly people who are not very healthy to begin with. What we're going to do is a skin punch of their somatic cells. We're going to remove these fibroblast cells from their skin, put them into a petri dish where they'll be dividing, and then we're going to add in these cellular reprogramming factors, the Yamanaka factors, plus 2 additional ones, 6-factor regenerative cocktail that will produce autologous induced pluripotent stem cells. And the good news about this is that these autologous cells are genetically similar or identical to the donor. That the elderly person who donated their old cells, we get their genetic profile, and then we reprogram those old cells into genetically identical induced pluripotent stem cells that we differentiate into tissue-specific stem cells that are then transplanted after purification back into the older recipient with the objective of inducing systemic age reversal. We feel by transplanting these induced autologous stem cells into the bone marrow, we're talking about hematopoietic and mesenchymal stem cells, we may be able to induce systemic biological age reversal. And here's how we intend to do it. Step one, we want to remove senescent cells from the bone marrow, get those out of the way, and then replace them with those induced autologous pluripotent hematopoietic stem cells to rebuild immunity, and also use the transcription factors to make mesenchymal stem cells to induce systemic regeneration of all the tissues outside the bone marrow. And to give you an example of how well this can work, this is something I showed at RAADfest 2 years ago, and these were old mice that had young bone marrow transplants. And you look at the young mouse microglial cell on the left, its branches extend like a healthy tree. And unfortunately, when that mouse grows older, those branches shrivel. It becomes dysfunctional. And you take an old mouse and put in old bone marrow, nothing happens. You take an old mouse and transplant young bone marrow into that old mouse, its microglial cells, synaptic branches extend again. They extend again and they regain functionality. So the brains of these mice are functioning better and their activity levels are improved. You look at the young mouse box on the upper left-hand box, it's gray, and you can see the mice running around a cage, really healthy. But the older ones, of course, they're slowed down, just like old people. But you transplant young bone marrow into old mice, and they start running around a cage and behaving like young mice again. Now, we can't transplant young bone marrow into old people because of graft versus host. And that's why we have a different plan in order to use induced autologous pluripotent stem cells to accomplish the same objective. And there's lots of data substantiating that this can induce a regenerative effect. The study published in 2020 showed significant reductions in mortality with very simple procedures compared to what we plan to do. And this study, published in May 2021, showed that progeroid mice, if you just put in transcription factors in vivo, you increase their lifespan and improve structures throughout their body, improve maximum lifespan in certain groups. So the evidence continues to accumulate that using transcription factors and reprogram genes in our cells to start expressing themselves in more youthful mannerisms. This group is doing something really unique. You send them your mesenchymal stem cells and they differentiate them into tissue-specific progenitor cells to regenerate maybe a kidney, a liver, a heart that's not functioning so well in your body. This group is doing work with autologous stem cell therapy to treat people with hematological malignancies such as leukemia, multiple myeloma. So we have research going on across the board, but it's not focused enough on aging. And that's why we plan to do a study in which we will take fibroblasts, skin punch drawn fibroblasts, replicate those cells, and then reprogram those cells into autologous pluripotent stem cells, repopulate the bone marrow niche with both hematopoietic and mesenchymal stem cells. Remember, these autologous, so the genetic profile is identical or at least similar, and then put those back into that older person to reverse immune senescence and rejuvenate their tissues. So our schematic chart here of what we plan to do to reverse aging. We hope lots of scientists out there see what we're seeking to do and copy us. I only have a few scientific groups that I'm funding right now, but there's hundreds out there that can do this exact same research and perfect it so we can start making older people potentially grow younger very, very soon. Now, I woke up to Apple hijacking my cell phone one Sunday morning with something I couldn't get off, and they were talking about science curing death. And I'm just going to play a few seconds of what they were talking about because they apparently knew I was interested in this and made me listen to this whole presentation, but it's very fascinating.
Can science cure death? It sure looks like it. Given the exponential advances in microprocessors and smartphones in his lifetime, he insists the biotech industry will figure out a solution by then. For this reason, Sarayev, like any number of young, optimistic, tech-associated men, believes that if he takes the correct preventative steps now, he might well live forever.
So what I'm going to do now is talk about what's transpired since last year's RAADfest. It's quite a bit, by the way, and the billionaires continue to put big money into age reversal research. And they're not doing it just to make money. They don't want to die. And this is what's really fascinating. And the continued publication, the continuing publication of research in which old plasma proteins are removed and it rejuvenates neurological function. It's consistent. This was published in November 2020 in Gero's Science. And this is something people are doing now. They're using apheresis as a way to remove plasma proteins to enable their brains to hopefully become more efficient. Tel Aviv University, November 2020, released the findings of a remarkable study in which they were able to use a very unique hyperbaric oxygen treatment to reverse aging. And the study was published in a journal, Aging, and it generated a lot of publicity. It talked about humans have found a way to reverse aging. This is fascinating, of course, and what they were able to do is use a unique hyperbaric protocol to elongate telomeres 20%, remove some senescent immune cells, improve some immune markers. And the media proclaiming for the first time aging has been reversed, which is not really true. Greg Fahey demonstrated age reversal 2 years ago. That was announced at RAADfest, by the way. But nonetheless, the media really is picking up on this information, and it's great because it stimulates other people to figure out better ways to reverse aging. And what was interesting about this study is that the trial participants, they saw their telomeres elongate to where they had been 25 years earlier. This is really remarkable. And where you can get this therapy? Well, it's available in North Central Florida at the Aviv Clinic. It's the first one of its kind to offer this technology in the United States. And when we sent our news correspondent up there to see it, wow, the pictures that came back, this looks like something out of a science fiction movie. What I'm going to do now is play a video so you can hear and see exactly what goes on inside these chambers.
The clients come into the hyperbaric. We close the doors and increase the pressure to 2 atmospheres. And the clients will fluctuate wearing a mask, breathing in 100% oxygen for 20 minutes. Then they'll remove the mask for 5 minutes, and then they fluctuate that 20 on, 5 off for the 2-hour session. During the hyperbaric, we have these tablets here, and our neurocognitive team develop training programs around what we've seen in each client's cognitive ability.
So they're not actually watching television. What they're doing is part of the process, actually.
Correct. They're not watching Netflix or listening to music the whole time. We want to actively stimulate the areas of the brain that have shown decline or have shown deficits.
So the cost to go to the Aviv clinics, a lot of money, $45,000. And for some people, it's a lot of time. This is a 3-month program, 5 days a week, 2 to 3 hours a day, where you undergo the hyperbaric chamber in a very comfortable position. You breathe in pure oxygen, and you also get cognitive training assessments. So for those who have the time and the money, this looks interesting. Another way, if you can't travel to the Aviv clinics, is you can go to a local hyperbaric chamber, and we priced it around. And to go in there 5 days a week for 3 straight months and breathe in some pure oxygen, it'll cost you about $18,000. It doesn't give you everything they have to offer, but at least it's more affordable, and you can do this where you live, wherever there are hyperbaric chambers available. But what we did is we interviewed the doctor overseeing this technology. That's me on a Zoom broadcast about a month and a half ago, and the doctor had some profound information to disclose. This again is pre-publication data, but they've done a new study where they've used a multi-prong approach, including intermittent fasting, to achieve average telomere elongation of 40%. I'm going to play a brief replay, a broadcast of what this doctor told us, which we broadcast, by the way, on local TV on a program that we have in South Florida. So listen to what this doctor says. It's just absolutely fascinating.
What we have over here, we have better results than the results we had in the clinical study. We have here prolongation of telomeres with an average of 40%, which is double the size that we had in the clinical study. Why? Because we are adding other intervention freely to the hyperbaric. Then the effect is synergistically.
So what he just told you corroborates what we've been talking about at RAADfest since the inception. And that is, you have to optimize the fundamentals of good health. That's level 1 before you move into experimental age reversal interventions. Because if you are fundamentally unhealthy to begin with, it may negate any benefits that we can enable you to obtain by experimenting with all kinds of therapies. So please stay healthy or get healthy today. Stay alive long enough until the time, well, when drugs like this become available. I'm again going in chronological order from last year's RAADfest, just a couple months after RAADfest. One drug used just a few times was able to restore cognitive function in aged mice. It was able to restore memory, it was able to prevent hearing loss, improve immune function. This is one drug, just a few doses, doing some miraculous work in these old mice. It's probably in the approval process now, which could take years, which is why we have to stay healthy now, waiting for these drugs to become available to save our life. And again, transcription factors. David Sinclair at Harvard did a fascinating study where they damaged the optic nerve traumatically, and they caused the mice to lose vision. And then they used just 3 transcription factors to regenerate the axons in the optic nerve to restore vision. So this is an in vivo, meaning in an inanimal model of using transcription factors to repair something that enabled the mice to see again, restoring vision using transcription factors to repair the axons, which make up the optic nerve connecting our eye to our brain. Fascinating research. So the end of 2020, Fortune's annual investor's guide. This is read by the titans of industry, big pharma, investors, philanthropists. This is what they look at. And what it talked about is the most exciting opportunity to improve the health of the world is to understand the biology of aging. They talked about what you've learned at RAADfest over the last couple of years about various age reversal interventions. And they talked about that if we fail to develop treatments to reverse biological aging, we're in for a healthcare cost tsunami. We're talking about Medicare and private insurance losing the money, going bankrupt, if we don't figure out a way to reverse aging in people today. And they talked about the need to launch an Operation Warp Speed against biological aging. This is fantastic. So January 7th, 2021, Wall Street Journal reports on a study in which progeroid mice, they got a simple CRISPR gene editing treatment, and they lived more than twice as long. And this study, if extrapolated on an optimistic basis to humans using combination CRISPR treatment, it could mean that this could enable people to live to be 160 years of age. It's really incredible. Now, a second study actually published the same day, January 6th, both those studies were published January 6th, showed that targeting just one gene using CRISPR, this is the KAT7 CAT gene, it's a significant driver of cell senescence. Just by targeting that with CRISPR, it extended lifespan in normal age mice, which is more significant to us than progeroid mice, extended lifespan 25%, it improved overall appearance and grip strength. And it's important to understand that mice and humans share about the same set of genes, though in different forms. And what that means is if this CRISPR therapy works as well in people as it did in normal age mice, we might be looking at 98-year average lifespans as opposed to the rather pathetic 77 years we're currently stuck with. So CRISPR is demonstrating continuous benefits as was predicted, and the media is reporting on this, getting worldwide coverage, which generates worldwide interest in funding and supporting different research projects. Now, the Financial Times, like the Wall Street Journal of the World, published out of London, and they talked about COVID being a disease of aging because, well, older people get it, die more often. And they talked about, though, anti-aging therapies that could prove as important in the 21st century as antibiotics were in the 20th. And if that's the case, if in this century antibiotic type advances in the anti-aging field are developed, wow, we're in for incredible, healthy longevity, incredible. And they mentioned that the pandemic, COVID, has left people frightened about getting old. That's good news. It means people are going to put money into it. WebMD is a rather conservative website. They talk about conventional medicine quite a bit, but they don't treat alternative medicine very well. I was shocked. February 2021, they talked about what we're doing to reverse engineer our biological clock and what our goal is. We don't merely want to eliminate disease. We're seeking to prevent death itself. And they brought out some examples, the immortal jellyfish and lobsters that seemingly live forever because they secrete this youthful enzyme. And this chart that appeared on the WebMD website is predicting by around the year 2065 that people may be living to around 1,000 years of age. And again, I emphasize, this is WebMD projecting that based on what's happening now and what we anticipate happening very soon, people are going to live a lot longer. This is almost independent validation of everything RAADfest has stood for since our inception. Wall Street Journal gave some really nice coverage to CRISPR in February about how it's going to defeat viruses and genetic diseases, enable people to live a long time. But then they criticized the fact that we may start making children smarter. George Church gave a nice rebuttal, and I'll paraphrase that. And he said something to the effect, well, who doesn't want smarter kids? And who would want a child who has learning disabilities, depression, other mental health issues? If CRISPR can prevent this from the beginning and make kids smarter, well, that's a fantastic technology, and it should be expanded on. So here we now have CRISPR being validated as effective and people raising moral questions. So CRISPR, clustered, regularly interspaced, short, palindromic repeats. This is our ticket to potential biological immortality. And this is the study that I talked about in the Wall Street Journal in January, in which they used a simple gene editing technique to more than double the lifespan of CRISPR-treated mice. The unedited mouse on the left, it looks old, 7.5 months old, and it's about to die. The ones on the right are CRISPR-edited mice. They behaved young at 11 months. They were running around a cage. They looked healthy. They weren't even appearing to be normal aged or progeroid aged, I should say, even though they were progeroid mice. And they get to live about 17 months, more than 2.5 times. And this wasn't complicated. All they did is they inserted a DNA base editor into an inactivated virus, and they switched the toxic progeroid genes, that's T and A red at the bottom, with some healthy C and G genes. And by doing this, they were able to achieve this remarkable benefit. But just to reiterate, they took a DNA base editor, put it into an activated virus, and then infected the progeroid mice with that virus. And the genes, the A and T, which are the progeroid genes, were replaced by the beneficial G and C blue genes. And this enabled the CRISPR-treated mice to live about 510 days compared to the unedited group of only 215 days. And again, an optimistic extrapolation, if we can do this in people, well, we're looking at about 160 years of life as opposed to the 80 years we're supposed to live now. The great news is George Church has already done it. A single dose of combination gene therapy yielded all of these benefits. And it's generated lots and lots of media coverage for George Church. I've shown these before at RAADfest. He's gotten incredible publicity, just absolutely incredible publicity. And other research into CRISPR is showing, well, if you modulate your genes, edit your genes, you can probably discard a lot of the medications you're taking because it'll keep your lipids and other pathological factors under control without having to take a bunch of pills. This is really incredible. The New York Times in March did a nice book review about two scientists who won the Nobel Prize in Chemistry in 2020 for their CRISPR-Cas9 research in engineering humans to better resist disease. This is getting national and international recognition that we are transcending towards radically extended healthy human lifespans. Now, we know about Dr. Barzilai. He is spearheading the metformin clinical trial at the Albert Einstein School of Medicine. That's been reported on quite a bit. He made a really surprising announcement in April 2021 that he expects very soon for $1 billion a year to become available to stop aging. This is mainly, he thinks, Mideast money in which they recognize writing $1 billion check is going to do nothing. It's got to be $1 billion every year until aging itself is cured. This is incredible news. In other words, the work we're doing to get the publicity and get the scientific community together and people start reading about the fact that we might be able to cure aging, they're starting to consider putting serious money into this happening. So the metformin study, it was approved in 2015. Nobody ever thought we'd get any funding. And the good news is, in March of 2021, a second metformin study was approved to treat frailty. This is based in San Antonio, by the way, Albert Einstein School of Medicine's in New York City. And, well, a third trial on metformin, on taking the metformin plus healthy eating and exercise to see if it can also reduce frailty, improve markers of senescence in older people. So what was first challenged is whether or not the FDA would ever approve a study on a drug to deal with aging. Not only did they approve the first metformin study, they approved 2 more. 3 metformin studies going on right now to see if it can slow or reverse biological aging. And well, we already know it can help because Greg Fahey reported in 2019 at RAADfest that you combine metformin with DHEA and growth hormone for a year, you get to reverse aging, 2.5 biological years. Fantastic. This generated international media coverage, and it's one of the reasons why money is starting to come out of the pockets of wealthy people, because they want to see their aging process go in reverse. The problem is the delays. Metformin was approved in England in 1958. It took 20 years for someone to put together a study to get the FDA to approve it to treat aging, and no one thought it would get any money, but it did in 2019, $75 million. Including $40 million from an anonymous donor. So that is way too much time for something to be discovered before it's tested in people. And this is the major impediment to us advancing the science into the clinical arena. Bureaucratic delays. We've got to break down these barriers so that we can gain immediate access to any therapy that can potentially reverse our aging process. So again, moving forward chronologically from last year's RAADfest, a potential shortcut until CRISPR is perfected, a way of highly specifically altering DNA methylation patterns to turn on those beneficial genes and silence the ones that cause us to prematurely age. They call this CRISPR-2, and while it's not exactly CRISPR, it's a way of using DNA methylation to activate those beneficial pro-youth genes and turn off the ones that are causing us to degenerate and age prematurely. Now here's an individual who I have a lot of respect for, Michael Grieve. He's putting in some big money to study a broad spectrum of therapies that could enable us to reverse aging in people today. Congratulations, Michael Grieve, for doing this. Rapamycin, we've talked about this for years at RAADfest, and a study came out in April showing it can help with Alzheimer's, at least if you're a mouse. We think rapamycin can help with a broad range of diseases. And the great news is a study that I announced last year, they had everything in place to do the study, but they had no money. And by virtue of me announcing it, some other publicity, they've raised $485,000. This is spectacular, and it's going to enable them to enroll study subjects at a low cost of only $360. I'm going to talk more about this study tomorrow at the clinical trials presentation that I'm doing. But the good news is the rapamycin study has gotten funding and people can participate at a very low cost. Senolytics, well, these are beneficial for every part of our body. But if we're suffering any type of kidney dysfunction, especially early stage renal failure, maybe senolytic treatment could get rid of the senescent cells in the kidneys and improve your kidney function. Anyone suffering from a kidney disorder should consider some experimental senolytic treatments that are being made available around the country. And great news as it relates to senolysis, the removal of senescent cells. The Buck Institute announced in June that they have been able to precisely measure the destruction of senescent cells in response to different senolytic combinations. And the USDA is funding research right now at Tufts University to make this measuring technology available to people, measuring the ability of senolytic drugs and nutrients to destroy senescent cells. We're partnering with the people at Tufts, our age reversal network, to assist in getting humans into clinical trials where we give them different senolytic drugs and nutrients and see how well we can measure the senolytic benefit of those nutrients, drugs, and other compounds. This is really breakthrough news that we're seeing. SIR2 and 6, overexpression, it's been shown to extend life in mice way back in 2012. 2021, study confirms that. median lifespan extended along with maximum lifespan by boosting a sirtuin 6 protein in our cells. So how can we do that now? Well, eat well. Olive oil, fasting, healthy vegetables that contain high levels of cyanidins. These all help raise the sirtuin 6 protein in our cells, and we already know they're good for us anyway. So healthy diet can help us derive the kind of benefits shown in this study. So amyloidosis, this is a protein misfolding disorder. There's a number of different types. This particular one I'm going to talk about is transthyretin amyloidosis, where lots of misfolded transthyretin proteins are circulated through the body. They destroy the heart, our digestive tract, our liver. It's a horrible, horrible disease. And guess what? CRISPR, for the first time in a human trial, was shown to reduce serum levels of this destructive transthyretin misfolded protein by 87%. This is the first time in vivo, whole human research using CRISPR has been able to treat a very serious disorder. It opens up the floodgates to using CRISPR to treat a whole lot of other genetic related diseases. The value of targeting aging, this was published just a couple months ago in Nature Aging, and it showed that if we can improve human life expectancy just 1 year, it's worth 38 trillion. If we can do it by 10 years, and we're looking to improve it a lot more than 10 years, 367 trillion to the U.S. economy. This solves the Medicare cost crisis and all the other unfunded liabilities this country is facing. And the great news is this kind of data has prompted at least a proposed federal budget, $6.5 billion, to study what they call gerosciences. They want to figure out a way to improve human life expectancy to save the federal government and private and public insurance companies a lot of money. This is all trending in the favor of what we've been advocating for decades at Life Extension and well since 2016 at RAADfest. Now, the GDF-11 is being used by some people already, but I helped fund a company in 2016, and they partnered with Harvard to bring GDF-11 to humanity. 2018 they started. I gave them a $100,000, essentially a grant just to get them started. And I was impressed. In August 2021, they raised $20 million, with $20 million more when the first patient is dosed with GDF-11. They're looking to enhance stroke recovery, treat obesity, type 2 diabetes, intracranial hemorrhages using GDF-11. Think if you have this in your body already, maybe you can prevent a lot of these problems from happening. We can't wait till this research comes out and we see how well it works. Sergey Young, he's got this longevity vision fund that invests in all kind of promising technologies aimed at enabling people to live many hundreds of years. We love people who are looking to make money at enabling us to live longer. It's an incredible mission statement, and we compliment Sergey Young and many others for following through on this technology. This study came out just about a month ago, and it showed that if you give long-term senolytic treatment to mice, it prevents intravertebral disc degeneration. And this is what causes chronic back pain and disability in people not just old but middle age. But nonetheless, we're continuing to see the benefits of senolytics in treating a host of degenerative disorders that people suffer from. And September, wow, was I surprised. I'm checking out at Whole Foods and I see Prevention Magazine. The cover talks about slowing down aging. And when I bought the magazine and opened it up, wow, everything we've been talking about at RAADfest, fasting, metformin, senolytics, everything was talked about favorably in prevention. And if you wonder why I'm so impressed, well, prevention, since their inception and our inception, we've kind of not agreed. And now they've come across to, well, agree with what we're doing and publish something that's extremely favorable. And I compliment them for doing this. We're garnering more and more mainstream people who are recognizing the technologies that we are pioneering have real-world applicability, and reversing aging, not a bad thing at all. So what we're doing is rewriting the rules of biology. 2006, this is what the Yamanaka factors were able to accomplish, and the Nobel Prize was awarded. They were able to reprogram old cells into young cells. In 2011, they were able to take cells from 100-year-old people and reprogram them back down into the induced pluripotent state. And we now are engaged in funding research that will attempt to do this in whole organisms, including people. And what has happened over the last, 15 years, the impossible has been transformed into biological reality. And we're conveying that message. We're getting the message out so people know that aging and death are not necessarily unavoidable. Biological rejuvenation is now something that's occurring in the laboratory model. We just need to translate that into human research, which again is why I funded this review of all the studies involving cellular reprogramming, and with emphasis on the 6 transcription factor cocktail that fully reversed the degenerative changes and fully regenerated old 100-year-old cells back into induced autologous pluripotent stem cells. We've already got the technology to do this in vitro in the laboratory dish. We've got some in vivo evidence. It's time to move that into the human arena. And guess who picked up on it? September 4th. What a nice Labor Day gift. Jeff Bezos is teaming with another billionaire to put big money into age reversal research. It seems like Jeff wants to live forever. That's what the media talks about. And his new company with another billionaire, they are going to pursue the cellular reprogramming that we proposed in the article we had published in February of 2021 as a way to revitalize entire people. They are going to spend almost limitless amounts of money, and they've recruited people like Steve Horvath and Dr. Yamanaka to put a team together of the most brilliant scientists, give them a blue sky budget, and figure out a way to reverse the aging process. The bottom line is we're succeeding in reaching the upper echelons of the investment community. People who make the impossible happen, they now are focusing in on age reversal research with the objective, live forever. It's absolutely incredible. The media reported on it. Cellular reprogramming. What we're focused on, we've got Jeff Bezos also doing it. And we don't care who succeeds. We just want someone to succeed in our lifetime so we can grow biologically younger. And again, this is our schematic of how we plan to use the ability to transform old cells into induced pluripotent stem cells that are autologous, meaning they can be transplanted right back into the bone marrow niche of older people to regenerate them in a continuous way. In other words, their bone marrow will naturally secrete huge amounts of hematopoietic and mesenchymal stem cells to regenerate them and potentially keep them alive for many, many decades longer than they normally would. So what's transpired since last year's RAADfest? Well, I think we're reaching the critical mass, that consensus in which people, I think, get it, that we are on the verge of reversing aging in people, and it's not that far away. And a lot of it has to do with published articles like I funded. It came out in February. It was funded by different charities that I am involved with. And the idea is let the world know that cellular reprogramming may hold a key to adding decades to our healthy human lifespan. This is an email from one of the scientists that I funded, and he talked about the fact that we've already rejuvenated old cells in human and animals, and there's 8 independent studies that show that different cell types from old humans can be rejuvenated by cell reprogramming. And all it's going to take is some time to achieve the same results in people. Just improve the technology in a way that old people can grow younger via the virtues of cellular programming using transcription factors. So how are we going to live long enough to make it into that incredible era, which may only be a few years away? Well, this is one way of doing it, intermittent fasting. And we know the major medical journals have published very favorable articles on the multiple benefits of intermittent fasting. Pretty much all the diseases that affect us with aging can be at least ameliorated, reduced in risk incident if we pay attention to how we eat. And this study came out right after RAADfest in Nature Research, and it's one of the more profound studies showing that we can just avoid eating from the time we wake up to the evening time, 14 to 15 hours, weight loss, blood pressure reduction, reduced risk of cancer, improved immune functions, maybe greater resistance to COVID. All of this simply by spacing out the time you eat by about 16 hours. In other words, about 16 hours, don't eat, and then eat during the 8-hour period, and you may become very healthy. Mediterranean diet, we sometimes forget that this results in a 25% lower risk of us dying. And a study came out in June 2021, 9.8 years of study time, that's a long time, 21,000 people. And people who eat the garbage food, fried foods, processed meats, their risk of death, 46% higher. Those who follow the Mediterranean diet, 26% lower risk of sudden cardiac death. So further validation that eating healthy can buy you lots and lots of time. We've been talking about the Mediterranean diet forever in Life Extension magazine, and it's important to remind people about the foods to eat. This is a slide that kind of shows the foods you should focus in on as far as your normal diet, and this kind of tells you what to avoid. Do not eat these foods. They will accelerate aging. They will increase your risk of degenerative diseases. Again, healthy foods, the Mediterranean diet. Focus on these foods, please, and avoid the foods that cause our bodies to get old faster, literally through glycation, oxidative damage, all kinds of carcinogenic activities. Stay away from the garbage foods. Here's an individual. He's 57 years of age, multi-billionaire, and he dies of a heart attack. And I'm thinking, wow, did that really have to happen? Was he getting his blood tested every year to correct cardiovascular risk factors? Because you look what happened since 1969. And this is when heart attack death rates peaked in the United States, 1969. And it went from 520 per 100,000 people down to just 167 in 2014. That's 68% decline in heart attack death rates over 45 years. Now, we intend to do the same with age-related disease in general. We're going to cut it down. But you got to pay attention. You have to have blood tests. You have to pay attention to your overall health, or you're not going to benefit. You're going to die like that individual. And most of us who were born attending RAADfest, well, in 1960, the average age of people dying in the United States was under 70. Kind of frightening because we want to live a lot longer than 70, and yet there's a way that's been identified that can add about 4.7 years to your already extended lifespan. And what happened in 2018, a study came out and it showed that people with an RBC, red blood cell score, that's a measure of long-term omega-3 status, just over 6.8% compared to those under 4.2%, well, they had a lower risk of death. In other words, just this one measure alone reduces your risk of dying. Now, that was one study in 2018. June 2021, a more elaborate study. This went on with 2,000 people plus over an 11-year period. And again, if your omega-3 index is over 6.8%, and it's not hard to attain, by the way. You can do it with cold water fish. You don't even need supplements. But keep it over 6.8%, and you can then live about 4.7 additional years. If you don't get any other takeaways from this year's RAADfest, this one, have an omega-3 index test. If you're over 6.8%, you're in good shape. And if you're under, well, do something about it. But it's a reality. Very wealthy people with a lot of money, they're often very generous. They make lots of charitable contributions, but they don't focus in on aging. And they have all this money and they wind up dying when they don't have to. They could have lived a lot longer. And this is really an interesting individual. He helped push through a cure for hepatitis C. This is one of those few true medical breakthroughs where an incurable disease, hepatitis C, was cured with a drug, Sovaldi. And this individual apparently walked to work, and he thought that was probably very healthy to do. And on his way home, walking home, he took a fall and he died. And I don't think when he woke up that morning, he thought that he was going to die that day simply by taking a walk and falling. But what this is an example of the frailty that occurs with aging that many of us are not aware of. We think we are as agile and capable as we were a couple years ago, and we're not. If we're over 40 to 50, frailty is there. It's slowly creeping up on us. So I advocate people, be careful. avoid falls. Don't take anything for granted. This individual, very successful, a lot of money, but he's dead because he took a fall. We don't want that to happen. And this is what I'm running into. More and more of our aging supporters are delaying intervening into their aging process. They're also delaying funding age reversal research. They reach a point where they're hanging by a thread. And then they come to me and they say, well, I'm ready for it. And I say, you're too frail. I'm afraid to do anything with you because you may die during the intervention. So don't wait till you're hanging by a thread to consider doing something about biological aging. So as it relates to Transhumanist Advances, New England Journal of Medicine reports in July that for the first time, they took a stroke paralyzed patient and they connected a transmitter to his brain in a way that he could transmit words from his brain directly onto a computer screen. Wow, a brain implant in a stroke paralyzed patient talking, not with his mouth, his brain talking to a computer and it translating what he's thinking into words. Our human brain cloud interface expert, Nuno Martins, was very favorable about this type of technology, validating what he's doing to eventually translate our consciousness, our entire being into the cloud if we want it. And Dr. Martins, he had a publication back in 2019 in the Frontiers of Neuroscience that described exactly how human brains are going to be connected to the internet in the next few decades. In other words, we're going to have a backup copy of ourselves in the internet. In the meantime, use our connection, our implant in our brain to talk to the internet, just like we use our cell phones now to get a lot of information immediately. And this published study that Dr. Martin put out, it got a lot of media coverage. The idea of merging our brain with the cloud is something that people are starting to recognize. And what was interesting is Dr. Martin's publication on the human brain cloud interface, it attracted more views than 90% of 67 other Frontiers in Science journals. There was so much interest in this from, well, guess what? Apple, Google, Microsoft, everybody thought this is the future. Once we establish human brain cloud interfaces, then we don't need cell phones anymore. We'll have an automatic connection to the cloud. And well, July 2021, that's been confirmed. Elon Musk, he's got a new startup, raises $205 million from Google and others to develop a Neuralink, where high bandwidth brain implants will communicate directly with computers and phones. Total investment in the company, $363 million. This is going to happen, and it helps fulfill the prediction of Ray Kurzweil. He talked about if we can just live to year 2045, we are going to merge the neocortex of our brain into the cloud. We're going to merge with the computer and then engage in limitless self-improvement cycles. And the result is going to be superintelligence that advances our abilities to the incomprehensible level of immortality. This is Ray Kurzweil's exit plan to achieve immortality, and it's being validated with research and money putting into this technology today. And for those who question if this is really going to happen, go back to 1903. Man had never been able to achieve heavier than air flight, and a glider with a little engine takes off and flies 120 feet. It makes international headline news. But the critics, and they're always out there, the naysayers, said this is never going to translate into anything meaningful. There will never be any such thing as flying buses. And 54 years later, they were proven wrong. Intercontinental jet air travel, just 54 years later, after the Wright brothers demonstrated you can really fly, they've got intercontinental jets flying all over the place. And then, well, 118 years later, we've got the rover landing on Mars. It wasn't the first time, but this rover had a helicopter on it. And this Wall Street Journal article kind of compared, well, here we were in 1903, man had never flown before, they prove it can work, and now we've got a rover all traveling around Mars with a helicopter that then flies around Mars and lands back on the rover and transmits data back on Earth. And by the way, we're controlling that all from Earth. This is robotic technology on Mars. So if you can see the analogies where until 1903, man had never flown. Once they show they can fly, then all kinds of expertise goes into developing technologies. So we go from 120 feet of Kitty Hawk to 140 million miles traveling to Mars. 2011, cells from a 100-year-old human were fully regenerated using transcription factors to reprogram the cells back into an embryonic stem cell phase where they can rejuvenate tissues throughout the body. 2022, we're looking to do large animal studies to see if we can use autologous induced pluripotent stem cells for systemic regeneration. Systemic regeneration. And I wasn't sure if I was going to show this slide, but I'm going to do it anyway. 1903, we fly. 2021, we're on Mars. Well, what if human lifespans could increase at the same rate as aviation and space travel? Well, the oldest living human died at age 122. Now, if we reach that escape velocity that Ray Kurzweil predicts, well, we could theoretically be living billions of years if the same numerical extrapolation is made. Just for the heck of it, I thought I'd throw that slide up there. This individual won't get the benefit because he's no longer around. And when you have a lot of money and you die, you no longer have any money. You don't have any legal ownership over it. It's now someone else's money. So if you have more money than what you need, I encourage you to donate money to organizations, charities that are doing work right now in an attempt to reverse your aging process, or invest in commercial companies. I don't care how you do it. Please spend some of your money before you wind up in this predicament. So this July, Apple talked about science curing death, and we know that that can stimulate other people to think, well, if they think they can do it, maybe I can do it better. Jeff Bezos is putting big money into technology that will probably enable humans to live a lot longer, including Jeff. Thank you very much.